Hello, physics, and welcome to Chapter 6. This is the first video for Chapter 6. In this video, I'm going to be comparing and contrasting elastic versus inelastic collisions. We'll talk more about momentum in the next two videos. This is more of a concept video than any math. So we're not actually going to do any math problems in this video. I know that's absolutely heartbreaking for most of you, but we're just not going to be any math today. Until you take the quiz this afternoon. So I guess there's some math there for you. So I'm going to draw a little chart here. So if we have two kinds of collisions, elastic collisions and inelastic collisions, there are four things that I want to kind of look at and compare between these two. The first is energy. Can't spell today. Momentum. Specifically VF. And last, we're going to look at the two objects after the collision. Or comparing before and after. Obviously, before they're not really interacting very much. So, in an inelastic collision versus an elastic collision, the fundamental difference between the two is the law of conservation of energy. In an elastic collision, energy is conserved. In an inelastic collision, energy is not conserved within the system. Now, what that means is, if we take the system to be the two objects that are hitting each other, in an elastic collision, the total energy that those two objects have is the same before the collision as it is after the collision. However, in an inelastic collision, the energy that these two objects have is not the same as it was before the collision. Now, the law of conservation of energy still applies. This doesn't break that law. The difference is that the energy is leaving the system. So energy is conserved. If we increase the scope of what we're looking at, we still see that energy is conserved. But if the system is just these two objects, there's sound produced, so that's energy leaving the system. If the objects heat up because of deformation, that's going to be energy lost. Any friction is going to be energy lost. But it's not lost, it's changing form, either creating mechanical energy in the air through sound, or becoming thermal energy in the objects or the air around it, or the any materials around it as it increases their temperature. So energy is lost in inelastic, but it's not actually lost. I just want to explain what that means. So, conserved, lost. In both types of collisions, momentum is conserved. Now, there is a caveat to that. The law of conservation of momentum says that momentum is conserved so long as the net force equals 0. And that is something we will talk about more when we actually look at collisions and the math behind the collisions. We'll talk about when that becomes an issue. Mainly in this class, you are not going to have to worry about impulse, other than you need to know that impulse is what happens that causes the momentum to not be conserved. So in both of these, momentum is going to be conserved. Now, VF, the final velocity of the two objects. Well, actually, let's start with VI. VI for the two objects may or may not be the same. It can't be, the VIs can't be identical because V is a vector. If the two vectors are identical, there ain't going to be no collision. They have to be different in some way. Either one is more Y and the other has more X, or they're opposite signs, move in opposite directions. If two objects have the same velocity vector, there's never going to be a collision. They're going to operate on parallel tracks. They're never going to intersect. So the VIs have to be different in order for a collision to take place. And that is any collision. You cannot have a collision if the two VIs are not different. Now, that said, VF could be the same or different. So for an elastic collision, the VFs are also going to be different because they're going to move off in different directions. But in an inelastic collision, VF has to be the same for both objects because they are moving off together. They stick together. That's one of the indicators of an inelastic collision. In an elastic collision, the objects rebound off of each other. They hit and bounce off. In an inelastic collision, they hit and stick together and either stop or move off in the same direction together. In either case, they have the same final velocity. And that's also the answer to the next row. Blanking, give me a sec. The objects are going to rebound in an elastic collision. And in an inelastic collision, they are going to stick together. And those are the fundamentals of an elastic collision versus an inelastic collision. There are more things here, but these are the main things that you need to know. Momentum is, of course, a vector. So that's something you're going to have to keep in mind. Since momentum is a vector, you're going to have to track whether it's positive or negative. In this half of this unit, you're going to have to track directions again. And like I said, I'll do special videos for 1D collisions versus 2D collisions. 2D collisions won't come out till after Christmas break, but 1D will come out before we go on break. So that's it for this video. I know it's kind of a short one, but hope y'all have a wonderful night, and I will see y'all later.